Okay, so we have another AMC problem. So this was number 20 on the 10B and number 15 on the 12B. So we have like a bunch of circles, and then we want to find the shaded region in terms of an expression. And what we know is like we have AB, B, C, and CD are given as 2 units. Okay, and then other than them, we also have a circle that has a radius of 2 centered at F, which means if you take this circle, and maybe it's good to highlight that. So this is given 2 units. But based on this, we know the other circles has like half circles has a radius of 1 as well. So we kind of have this already. So this guy and this guy and this guy also has a radius of 1. But the shaded region doesn't look fun. So what I will try first to split this shaded region into some other region that I actually can easily handle. Since you know the F is the center of the larger one, so I'm gonna connect E to G, since this is like symmetric through the point F, which is center of the larger circle. So this region right here will be half of the larger circle, which is easier to find the area of. So I'm gonna kind of do that part because that's the easier one. So if I want to find this region, that's gonna be just 1/2 times pi times the radius square, which we know that's 2 square. And that is something we already know. But the second thing I'm gonna try, you know, we do not want these half circles, but there is some shaded region right here. So like if I need to know this region, which actually one of the common funky region when you are dealing with a circle, we are gonna need to find these two right region. But to do so, what I will try is connect this point E right in the middle of AB, and the same as the point G to the in the middle of CD. So we actually have a rectangle. Why this is matter? Because like when you take a look at this guy, which is 90, and then we drop the altitude, these are 90s. So we may find the area of the rectangle and then subtract these like quarter circles and this half circle to get the shaded red region. But the red region now is good because we know the radius of those half circle was 1. So one side is just 1. And this like is 1, and then this is 1, that's 2. But BC is also 2 because the radius of this half circle was 1 as well. So that means this side will be just 4 units. So the area of the rectangle is 4 times 1, which is 4, and minus, yeah, this half like quarter circle, and the quarter circle will make half circle, but there's another half. If you combine all these, you get just one complete circle, which will be the area we need to subtract. And the radius of that complete circle is 1. So that means 4 minus pi is actually going to be these two red region, which is also nicer. And the only region that we were not able to get EM is just the region that is lower than that side, like AD. So, but that looks a bit different than the other two regions that we were able to get. So, which is why I'm gonna clean this a bit. Okay, so, and then I'll see if we can do something else. Like if I connect this endpoint to the center of the larger circle, and then this endpoint to the center of the larger circle, that will make a sector region. So if I have somehow the area of this triangle, then I can subtract from the sector to get this region. So which is not too bad either, but only thing is I need to know the angle right here because I know the radius is 2. So that is 2. So maybe we can drop the altitude because we are gonna need to find the area of this triangle. And we also know this is 1 unit because that's the radius of the half circles. And we also know this distance is gonna be the total of like we can find it by using Pythagorean because we know this is 2, this is 1. That means this is actually 36 to 90 triangle because ratio is 1 to 2. That means this guy right here should be 30 degrees, and the end this angle right here should be 60, and this has to be 60 as well. So if that's the case, we have this is sector, that's the central angle is 120, which means we are gonna need, I'm gonna write this separately. So 1/3, because 120 degrees times pi times radius square minus, we want to subtract this triangle, but we know the height, and this guy should be known. So we know this is 30, 60, 90, so which was just √3, and that's also √3. So then the area of the triangle will be just like height times base over 2. That's going to be 2√3 times 1 divided by 2. That is just √3. So that was pi times radius. Okay, so that's going to be 4/3 pi minus √3. So this is the region, is going to be this shaded region. So now we just want to add all these together. So that means plus 4/3 pi minus √3. So let's clean this a bit. So this is 4/2, which is 2 pi. So that should be 2 pi. And then we got 4. And then minus pi. And then that would be 4/3. It's pi minus √3. So this is promising because the expression we're expecting was also a bit fancy looking. So we have 2 minus 1, that's 1 pi. If you add this to 4/3, so that should give us 7/3 pi. Okay, that looks like this. And a minus root, so I'm going to say minus √3. And the constant is just 4. So we want to find the A, B, C, D. A is 7, B is 3, C is also, and then D is 4. So that's 10 plus 7. So that looks like my answer. So again, this was a number 20 on the 10B, so meant to be challenging. But as long as you find a way to find the region that you are looking for, so the question wasn't like to involve. So sometimes we kind of need to split the region into some different regions, which was the main approach, I guess, in this problem. So I hope that was clear. Anyway, I'll see you in the next video.